Ananya, we can start now.
We are going live, ma'am.
Okay. Okay. Good afternoon, one and all. I hereby welcome you all to this 17th Women in Science event, which is being held in collaboration with INYAS, Punjab University, Association of Microbiologists of India, and also Indian Science Congress. And today we are extremely privileged to have with us Professor Indupal Kaur, our very own faculty from Punjab University, who in herself is an icon. She's an inspiration for all of the young faculties to learn from her. Before we start the program, I would like to give you a brief introduction about what is Women in Science. So this program has been initiated for around 2 years back. And the main objective of this program is to highlight the achievements of women scientists, women faculty members, and also of the female research scholars. So in these directions, we have already held 16 webinars, which included some webinars, some panel discussions, and we have had guests from around the globe, and it has definitely inspired our young girls, the young students, to take up their way forward in STEM. So now, before we start our program, I would like to invite Professor Praveen Rishi to please introduce to us about AMI. Ma'am, please.
Thank you, Dr. Nishima. Honorable Professor R.C. Sopti, the guest of honor for today's event, Professor Indupal Kaur, the distinguished speaker of today's event again, Dr. Nishima, the moderator, and her team, and other esteemed colleagues and students, my greetings of the day to you all. It is indeed a matter of pleasure and great honor for me to be here in front of you at this platform and talk to you in the capacity of President of Association of Microbiologists of India. And you know, AMI was established way back in 1938 and got registered in 1951. And it is one of the oldest and the most reputed scientific organization in the country. And ever since its inception, continuous efforts are being made to strengthen this association. And as a result of all the efforts put in by the AMI officials, now we have got around 5,238 AMI members and around 450 corporate members. And with this, we have also got around 42 units which are spread across the country. So the association holds the national convention every year at one of the well-established centers of microbiology in the country, in addition to several other events which are organized by several units in the country. And this year, 62nd annual conference is going to be organized at the University of Mysore.
This meeting is being recorded.
So it is being organized at the University of Mysore, and all of you are invited and make your participation, because I understand that whatever field we are working in, you know, earlier we used to work in silos. Now the time has come that we have to cross the boundaries and come and work with the multidisciplinary approach. So everyone is invited and we can just collaborate with each other to come to the meaningful conclusions. And moreover, under the ambit of AMI, we do have Academy of Microbiological Sciences, which confers fellowships to the eminent scientists in this field. And the association has also been publishing a quaternary journal, which is Indian Journal of Microbiology. It is published by Springer, and it has attained a respectable status among the national and the international journals. So having all these things said, the ultimate aim of the AMI is to exploit microbes for their diverse applications and ultimately to meet the societal needs. And of course, you know, after having learned so much from COVID pandemic, it becomes all the more important to promote this subject and to spread awareness in the amongst the general public, particularly particularly amongst the children and the economical weaker section of the society. So this is all about AMI. So I thank you so much. I look forward to Nishima, please. Over to Nishima. Thank you so much.
Thank you so much, ma'am. Thank you for letting us know about Association of Microbiologists of India. It was indeed great to know about its history and what all AMI is currently doing. So I'm extremely honored. We all are extremely honored to have Professor R.C. Sobti with us today as our guest of honor. We all know him at Punjab University, but I would like to give a brief introduction. And Professor R.C. Sobti is an Indian educationist and cell biologist. He graduated in science with honors from Punjab University in 1969 and later on secured his master's degree in 1970 and a doctoral degree in 1974 from the same institute. His early researches were linked to cancer biology, and some of his writings, I think sir wants to say something, but probably he's mute, which comprised 22 books and 246 articles, were based on his cancer researches. 156 of his articles are reported to have been cited over 2,000 times with an H index of 18 on ResearchGate. He has been elected as a fellow by various national and international academies like National Academy of Sciences, National Academy of Medical Sciences, National Academy of Agricultural Sciences, International Academy of Cardiovascular Sciences, Union for International Cancer Control, and the Comprehensive Cancer State of Florida, etc. In 2006, he assumed the responsibility as the Vice Chancellor of Punjab University and continued in the post till 2012. The Government of India awarded him the fourth highest civilian honor of the Padma Shri in 2009 for his contributions to literature and education. When the Indian Science Congress Association conducted their 101st annual session at Jammu, he chaired the session as its general president. He has also served as the director of the National Research Development Corporation, NRDC, and as a member. Okay, sir. There is actually so much to tell about you.
Let's move on.
Okay, sir. Okay. And he headed the panel of NAC also, and we are extremely lucky to have him with us today. And I will request Professor R.C. Sobti to please say a few words.
Thank you, Dr. Nishma, Dr. Rishi. I'm really surprised at how come amongst women I'm here. Of course, whatever I am because of the women force at my house and in both in my mother and my wife, and of course now my daughters. So whatever I am because of women force over here. So that's why I didn't mind accepting this very assignment, whatever you assigned to me, to chair the lecture by very prominent teacher of this university, Punjab University, to whom I admire a lot, not now, for the last about 20 years, when she was just an assistant professor. I happen to know him through one of my students who is in America. This is sure that there is a gender inequality in our country or in the world itself. I know it is there in America, it's in Germany. Women folk is not given the same salary as the men are given over there. I've seen myself. But definitely, the women have contributed to the society, rather creation of this world in a much bigger way. You name any area, science, technology, arts, culture, politics even, they have wherever they have entered, they have excelled. And we know that there are so many women scientists, if you talk about science, who have done wonderful job. And particularly if you look at the COVID-19 period, what women have done, men have not done that way. Because they were much more than frontline workers, as a clinicians, as a nurses, name any area. And above all, they changed the family system, rather brought in the old system what we had in our society, and also took care of the whole family, beside taking care of the society as such. So we are proud of women. The word would not have come up to this level had the women been not there. In India, we say, Nari ek Shakti hai. If you look at it scientifically, it is true. Whatever energy I have, I've got from my mitochondria, which have been inherited from my mother. My father has not contributed to any energy level. He just contributed 23 chromosomes, but the energy has been contributed by mother, and it goes on. So that's to say women, the Bharati Sabhita, a Shakti, she is really Shakti. So whatever you look at the Indian culture, it has a meaning. Nothing can be said without it. And that is why we have, when we have this Durga Puja days, before that, what we have in Indian culture, that we remember our parents, grandparents who are not in this world, what they did, what we have inherited from them, and then we, in order to regain energy, we have a Durga Puja. That so that next 6 months you can perform your duties in a much better way. So ultimately, we bank upon the women for everything, whatever we have. And scientifically also, today, even men are not there, women can carry the world alone. And you know that what is the artificial, all those things are there scientifically, and in the Palkar knows better. And we could not have much the better speaker than Indu Palkar here today. She has excelled in her field, starting from genotoxicity, and she is doing wonders in drug repositioning as well as the tissue regeneration. Name any area, she has a publication there. That is why she is amongst the 2% of the scientists in the world. Whatever the data came, the global data, she is among the 2% scientists. She has so many awards to her career. Of course, she started as a temporary lecturer to professor, and she's heading the department of the University Institute of Pharmaceutical Sciences in best possible way, in a cordial way, and also only women can do that. Wherever men are heading, there are some problems all the time. But I know when I was a vice chancellor, I assigned whatever duty I assigned to Dr. Gopal Kaur or Dr. Renu Vej, or Rajesh Gill, they performed their duties in a best possible way. Because when Dr. Renu Vej was appointed director, there was a lot of challenge that she won't be able to perform. Let me tell you, within 6 months, she transformed UIT, which was there for so many years, but the way she worked, she controlled the institute in a much better way. And now she is having the Dean's University instruction, a very responsible position. She's doing it. Same way, Dr. Indu Palkar has a very bright future. Her CV is a very, very long. If I start reading that, it will take full day, and we'll miss her lecture on a very important topic. That is, she is going to talk the innovation in new era, options for skin diseases and tissue regeneration. Because this is enough time when we are talking about the organ on a chip, and which is a combination of all the technologies. And then if we talk about the tissue engineering or regeneration, we need all that knowledge, because we have now artificial skin there. We are going away from the chemicals and all those things, coming to the biomaterials. Particularly, it has come for the skin or for the trachea, and even people are trying to have the kidneys as such, beside repairing certain organs. And eyes are already in India, the work is going on. The cornea replacement, all those things are there. I won't take much time, but definitely I must thank Nishma ji for doing a wonderful job. That's an Indian national young scientists, this forum what you have. Keep on doing it. We are with you. Of course, we are now burnt candle, but definitely people like you have a future, and the whole country is proud of you because the future of science, future of technology, or the future of country lies in you, in your hand. And I am sure that the people like you will do wonders in the coming years, and especially Punjab University is proud of all of you and the women force. I remember again. I went to whomsoever, whosoever women was, I gave a responsibility. I didn't have to look back again. I have given a responsibility to the wrong person. And same experience I had Lucknow at the BPAU, that's a Baba Saheb Ambedkar Central University, Lucknow. So please keep on doing it, and we feel that this work will continue. It will bring in many, many more scientists to educate or to give a spark to the young students who are aspiring to be good scientists for the development of this country as well as the globe, to bring peace, prosperity, and happiness among the society. And if that is there, then only the teacher can do it, or the science can do it, technology can do it. Technology has many adverse effects also, and that is happening in the warfare and all those things. But the growth and development will depend on science and technology. If you want to solve the problems of agriculture, health, or environment, only science and technology can do, and our young colleagues will see that it is done. Thank you very much, Praveen ji. Thank you, Nisha ji. I look forward for the lecture of Dr. Indupal Kaur. Like she's like my younger sister, Dr. Indupal Kaur.
Thank you, sir. Thank you so much for your really nice and encouraging words. I'm highly charged after listening to you. And I really feel that, yes, it is true that we have the responsibility on our shoulders. And I assure you, sir, that we will work really hard and we will abide to your words, and we will be just like what Indu ma'am is. So thank you, sir. And before she starts her lecture, I would like to give a brief introduction about her. Although, as sir, you rightly said that it's a long, long CV and it will take me the whole day to read it. So I have just compiled, she has in fact sent me a very crisp CV of her. So I will just read it out to you. So she's amongst, and we are very proud to say that she's amongst the top 2% most cited scientists across the globe as per Stanford University, US 2020 as well as 2021. Her research forte is enhancing bioperformance of drugs, plant extracts, phytochemicals, and biomolecules with siRNA, proteins, peptides, probiotics using actively tailored SLNs, nanovesicles, and electrospun scaffolds. Her group has worked extensively on novel platform nanotechnologies to overcome delivery challenges of molecules like antifungals, antituberculars, retinoids, anti-glaucoma medications, and posterior eye delivery for AMD and diabetic retinopathy. She has produced 26 PhDs and 55 postgraduates and has received funding of around 100 million INR from government and industry. She has delivered 50 invited talks and published around 150 articles with an H index of 45. She has 8 books and has more than 20 book chapters to her credit. She is a US Fulbright Fellow 2017-18 and was awarded Women Scientist Award 2018 by OPPI. She was graced with BRIC Technology Exposition Award consecutively for 2 years, 2019 and 2020, Researcher of the Year Award 2019 by Sunpure Research Incubation Center, and won the Grand Innovation Challenge conducted by Indian Pharmaceutical Alliance in November 2021. She has received funding for project and beamtime application for the ISIS facility Rutherford Appleton Laboratory, UK 2017 and 22. Emphasis of her work lies on industrial and clinical translation and is reflected through licensing of 4 of her technologies to pharmaceutical, biotechnological, and dermaceutical industry, and 33 filed patent applications, out of which 12 are granted, including one US. And currently, she is the professor and chairperson of UIPS. And before that, she was also the director of the Sophisticated Analytical Instrumentation Facility of Punjab University from 2012 to 15, the Dean Faculty of Pharmaceutical Sciences from 17 to 18, Secretary of Indian Pharmaceutical Association Punjab branch since 2017, project coordinator UGC NRC program UIPS, and the president of the Punjab University Pharmaceutical Society. Ma'am, indeed, it is a really inspiring CV of yours, and we wish we could also reach someday to your level. Please keep guiding us. And now I would request you to please, we are really waiting to listen to you and your journey, your accomplishments, and your science. Please, ma'am.
Thank you so much, Dr. Nishima, for a very kind introduction. At the outset, I would extend my gratitude to Professor Parveen Rishi, presently who is here in the capacity of the president of Association of Microbiologists of India, but she is a dear friend and a very, I would say we are very passionate collaborators in science also. At the same time, I'm really grateful to Professor Sopti for his kind words. I would say he is in a way my mentor. As he says, the association goes back to when I was a student and he would visit my, research guides, and I was introduced to him at that way. And then he actually reposed great faith in me when he assigned me the duty of being the director of the Sophisticated Analytical Instrumentation Facility of Punjab University. Thank you so much, sir. And I also extend my thanks to the Women in Science and also the Indian National Young Academy of Sciences and the Indian Science Congress Chandigarh chapter, for which sir was earlier the former president of ISC. So I start with my presentation. So this is the title for my talk. Since it was in conjunction with the Association of Microbiologists of India, so I thought it appropriate that maybe I can have a title which would, do with innovations, science, and also with, some microorganisms, basically probiotics. And several of the work which I'm going to cite today is in collaboration with Professor Parveen Rishi as well. So this is the structure of my talk, which would include a brief introduction to our university. I don't know how many of the people will be watching from outside the university. I would briefly introduce University Institute of Pharmaceutical Sciences, talk about the skin microbiome and the dysbiosis, the role in disease and immunity, the scope and issues for skin where probiotics can play a role, and some case studies from my lab. So I have taken two pictures from Punjab University, and we are very proud of our university, which is amongst the oldest and a highly recognized university of India, sprawled over several acres of land in two sectors of Punjab University with two campuses. So I belong to an institute which was incepted way back in 1944. So we are more than 77 years old, and we are consistently claiming the All India rank 2 amongst the pharmaceutical institutes of the country. I have, to my credit, almost 30 years or more of research and teaching experience. And as Nishima has already pointed out, I started from a genotoxicologist. As Sir said, my PhD was in the area, but then I moved on to be a formulation scientist. That is how I now introduce myself. And I have been working towards solid lipid nanoparticles, nanovesicular systems, and probiotics is something which is very close to my heart. And I really feel very passionately about the scope of these being the next era options in the therapeutic arena. And this is the view of my institute. This is the front building, and this is the extension block. And as I said, we are 77 years old. We have had almost 11 technologies transferred to the industry, which is a great feat for a small department in a state university. 8 of our products are in the market, and we have a significant citations, and 10 out of our faculty members are amongst the most cited, not only in Thomson and Reuters, but also promulgated by Stanford University recently. So why I took this topic? So this was a recent publication in Nature, Impact Factor More Than 40 on 26th May 2022, where they are talking about microbiota and the maintenance of skin barrier function. People are talking in Cell Host and Microbe. This appeared in August 21, where we are talking about commensal microbiota, which can regulate the skin barrier function. We are exploring the challenges to manipulate the human skin microbiome. So what is this now? Skin microbiome. Skin, if I talk, is the largest organ by weight in the body, and it is colonized by a diverse set of microorganisms. Almost 10⁶ to 10⁸ cells reside per centimeter square of the skin. So when we talk of humans, I would say we are basically an amalgamation of what we are as a body, the macroscopic host, and our symbiotic relationship with the commensal organisms, which are present both majorly in the skin and in the intestines, especially the colon. So we may be referred to as meta-organisms. So we are what we are, not only because of the mammalian cells, but also we actually, the functions are contributed to an extent by the microbiome which is present in the body. Initially, we used to say if you take the proportion of the bacteria to the nucleated human cells, then it is a proportion of 10:1. So you can very well imagine the importance that the immune function to the genetic markers to everything, the physiological effects would be contributed in a way by the bacteria which grow on or in our body. If I include the RBCs also, still the ratio is 1.3 to 1 in favor of the, not only, I would not say bacteria actually, we are a amalgamation of, there are certain fungi like Malassezia are very common on the skin, and some bacteriophages are also there, but in the gut, more or less, bacteria are present. So this, now the microbiome is monitored by a diverse skin surface. There are oily areas, there are moist areas, and there are dry skin areas. Dry skin areas have most diverse habitat, but smaller number of organisms, while the moist area have maximum number of organisms, and the oily or the sebaceous areas have very few organisms. And so the topography, the host factors, the environment factors like pH, temperature, moisture, sebum, then the extrinsic factors like aging or exposure to UV rays, and there could be certain other intrinsic factors like the genetic makeup and so forth. The skin majorly comprises of immune cells like keratinocytes, sebocytes, and some Merkel cells. And then these immune cells integrate with the microorganisms and the metabolites they are producing and the type of immune reactions they are showing. And there is a very fine balance between the two. And as soon as this balance is disturbed, there is a dysbiosis, and this dysbiosis can manifest in form of several diseases. And the skin, being the external organ, also manages it is like a protective barrier to infections and also to any other environmental factors or the chemicals. So here what I want to show is that as I said, the skin is covered by bacteria, fungi, demodexes, etc. And then the host cell as well as the microorganisms. Both are producing these antimicrobial peptides, and these antimicrobial peptides monitor a part of the immune response, and there is a quorum sensing because of these AMPs, and which would control or balance the pathogen to the good bacteria on the skin surface. Then we have the dendritic cells, the macrophages, the lymphocytes, all of which they formulate a part of the antimicrobial defense against the onslaught of any infections into the skin. The sweat gland is there, the hair follicles are there, and then as I said, the AMPs are majorly being produced by the sebocytes and the keratinocytes, and then some sweat glands, there could be a production of some antibiotics within the cell like lugdunin, and this controls the immune response and also the infections by one of the very notorious bacteria like Staph aureus. Again, this slide, I want to show that the microbial metabolites like oleic acid could cause skin disruptions. Then lipotecoic acids are produced, which maintain the lipid barrier of the skin, and certain other porphyrins are produced. So as I said, antimicrobial peptides are produced intrinsically, and they maintain the microbial balance. So the microorganisms may reside on the skin surface and majorly into the appendages, as I said, like hair follicles. Sebaceous gland is highly covered by the organisms it does. So many a times they say the organisms are not only present on the surface, but on the internal layers. There have been studies where they stripped the upper layers of the skin, several layers, up to 10 layers. And then what they observed was that the skin flora, which again appeared on the surface of skin after regeneration, majorly comprised of the flora which was present in the lower skin layers. And the host AMP and IL-1 are produced. Then similarly, the AMPs are also produced by the microbes. And then there are certain interleukins produced which have an anti-inflammatory action. And all of this goes on to be protectants. So why skin? So if I compare the microorganisms of the gut versus the skin has a lower microbial content versus the colon. The diversity is also lesser, except that the gut flora majorly comprises of bacteria, while in case of the skin flora, almost 10% are fungi, and some viruses and bacteriophages are also there. Then the major niche area is mucous epithelial surfaces and crypts, while in case of skin, they reside on the surface and the stratum corneum, the outermost or the dead skin layer of corneocytes, and also in the appendages. The establishment in case of gut is from the start of the life at the birth. So the during the normal delivery, the fetus takes up the gut flora from the vagina of the mother. And in case of cesarean delivery, the gut is sterile, and the child, it acquires the flora as it grows. And that is why there are several studies where they claim that the cesarean children are more prone to skin infections, allergies, atopic dermatitis, in addition to other problems. And many a times the children who are exposed to antibiotics at the time of delivery, or neonates, again, in those cases, the gut flora is more skewed towards some pathogenic organisms. In case of skin, the acquired flora changes at the time of puberty as well, because there is a change in the sebaceous glands. Then as far as the nutrients are concerned, the gut flora is supplied by rich nutrients, and a different type of flora would be there. While in case of skin, the skin is always exposed to the atmosphere. So they are adverse conditions, and it is majorly the peptides and the lipids on which the flora has to survive. As far as the immune function is concerned, both of them play a very important role in immune function, and the effects are seen both locally in the case of gut, as well as also systemically. You can see the effects of the gut flora. While for systemic effects, we are not sure if the skin, there are now studies where they say there are neuronal endings in the skin, and skin is also being referred to as a second brain for the body. So people are anticipating that there could be more to the skin flora than what we know till now. So what happens if the, this skin balance is disrupted? So there is a translocation of the microorganisms which are mediated by host predispositions. Then several metabolic diseases have been associated with dysbiosis, and there could be a normal barrier breach due to wounds, due to UV exposure, or any other, infections or allergies. And as a result of which, there have been incidences where the flora which are present normally on the skin, for example, a Staphylococcus epidermidis is very common on the skin, as is considered to be a favorable bacteria, but it could turn into a pathogen due to this barrier breach. And similarly, in infections, the skin microbes may cause inflammations, tissue damage, and several times to manage these infections, we treat the skin with antibiotics, and these antibiotics then also tend to lead to dysbiosis. And so now the concept, हमारी नानियां और दादियां, they used to say, बच्चे को मिट्टी में खेलने दो, उसको मत रोको. And then an era came when we would keep our child very clean. We would not leave them into the floor. We would say infection हो जाएगी. हम लोगों के टाइम पे हम teethers भी boil करके देते थे बच्चों को. And that was a hygiene hypothesis. So now from the hygiene hypothesis, we are again going back to the biodiversity hypothesis, where it is considered very important that the child is exposed to all types of environment and organisms to acquire a healthy microbiome, which would be very important for the subsequent health. So again, I come back here where I say that there could be a breach either because of infections where pathogens can move in. There could be a genetic predisposition, as I said, in case of allergies, atopic dermatitis, psoriasis, and things like that. And then there is a change in the microbial composition, which would lead to production of AMPs and keratinocyte proliferation, which leads to inflammatory cytokines and toll receptor ligands. Toxins are produced. This could be also because of the presence of pathogens, any infection, and so forth. So what are the approaches available for skin disorders? We have antibiotics, but invariably these we do not have very many options for local antibiotics except for one or two. So invariably they are given orally, and when we all know that oral antibiotics lead to the disruption of the healthy microbiome of the gut, leading to diarrhea, GIT distress, and then toxicity is also known by several antibiotics. And then we are now faced with the challenge of antibiotic resistant strains. Then there are certain herbal options available, but then again, because of poor standardization or limited documentation of data, we are not sure what herbs are safe, in what quantities they are safe. I was reading the literature, and during COVID, we've been recommending certain herbal concoctions, but the limit of consuming those herbal concoctions were not educated to the general public. And there have been so many cases of diabetes which have been reported because of the inappropriate, or I would say limitless use of some herbal drugs. Then allergic dermatitis is also reported. There are certain drug interactions which are reported with some herbal drugs, and the herbs could be contaminated both by microorganisms as well as by some heavy metals. So again, that becomes a concern. And similarly with antiseptics and antimicrobials, they are invariably non-specific. They would alter the normal flora, lead to further dysbiosis, and a vicious cycle sets in, and this dysbiosis leads to more infections. They could be toxic. They could interfere with the natural healing process of the skin and patient compliance. So this is where we are. This is what I want to talk about today, is that probiotics could be an answer. So this is what the probiotics do. And one of the approved definitions of probiotics are live microorganisms, which when administered in adequate amounts would confer health benefits to the host. They are now being evaluated for their potential in control of various skin conditions, and the mechanisms are diverse, right from production of AMPs to inhibition of pathogen adhesion to the reduced colonization or competitive colonization of pathogens, and also immune stimulation. Then the most common organisms which have been studied are Bifidobacterium, Lactobacillus, and also E. coli and Saccharomyces. So again, I want to reiterate here that now, earlier I was trying to show that people are talking about the skin microbiome and the role it had to play in the skin barrier and the barrier dysregulation. And now what I want to show here is people are talking about how to deliver these probiotics onto the skin, how to deliver them live onto the skin. So there are studies where biomaterial-based encapsulated probiotics are being used. We are talking about topical probiotics. We are talking about the application of lotions which would change the skin microbiome, and then pharmaceutical dosage forms of probiotics, and also some other crosstalks. And they are all very recent studies, 2022, 2021, and so most of them are actually in 2022. So topical versus oral probiotics. So when we talk of oral probiotics, there are diverse applications, but in relation to skin, if I talk that how can you administer oral probiotics and change the skin flora or achieve treatment for skin diseases, it would be majorly through the immune function regulation. While in case of topical treatment with probiotics, we know that in case of compromised skin, it is open to the onslaught by the allergens, then organisms like bacteria and viruses, then a ceramide secretion is decreased, overall skin health is also compromised. So the probiotics, they can have an antimicrobial effect and prevent the infections. They generate ceramides like sphingolipids and lactic acid, so which would ensure or regenerate the barrier. Then they are also known to have to produce a certain cytokines which would manage the inflammation. Then they also restore the hydration and elasticity of the skin, and also remodeling of the epidermis and the dermal tissues. So what are the choices with these probiotic interventions for the skin? Now, this is where the challenge lies. Do you apply live probiotics or dead? Do you use a single strain or a multiple strain? Should it be used as a prophylactic or as a therapeutic? What would be the treatment modality, and how do you deliver the probiotic? So there are studies where they say that the antibacterial interference would actually be better with the live organisms, but as far as the host immune system and its modulation is concerned, even the dead bacteria can work. Similarly, there is always a concern about the virulent genes being transferred to the the host cell or the mammalian cell. That would not be a concern with the dead cells. However, it has been observed that the probiotics, when administered live, are found to be very safe, and no such transmittance of the genetic material has been observed. So there is no need to limit the use to only dead bacteria. Multiple strains are known to have synergistic effects, but their standardization could be an issue. And in what proportion should you mix them, and how do you control, and how do you conclude that what effect is because of what strain? That could be a limitation. And then you have to be very careful about the cocktail which you are preparing, about what you are mixing. One wrong push could spoil the entire tank. So you have to be careful when using the multiple strains. Then we need to actually shift. This is what I advocate now, is that we try and evaluate and also develop probiotics as a treatment strategy. And to play safe, invariably people want to start with antibiotics and then stop the therapy, and or you concomitantly administer the antibiotic and the probiotic and then continue with the probiotic therapy after the antibiotic. But there have been reports and studies where only probiotic has been also found effective. Then the probiotics as a topical therapy has more potential than if you just administer them into the gut, where they are just modifying the immune system. And there could be local and commensal bacteria, which would be the ecological niche of the gut is entirely different, as I showed previously, than the skin. So what are the limitations when you try to manage skin diseases by oral probiotics? As I've already, I think, explained, they may not, there could be, issues. That is another area where even when you want to administer oral probiotics, again, you have to ensure or encapsulate them so that they survive the adverse, conditions, especially in the stomach where the pH is highly acidic, and reach the colon where they establish themselves. So same limitation would be there when you are trying to administer probiotics orally for their effects in the skin. And again, as I say, there have been observed that there are transient changes upon probiotic therapy, and as soon as you withdraw the therapy, the prior microorganisms or the microbiome re-establishes, and the major effect would be immune system mediated and would not be due to antibacterial effects. So it is important that we directly manipulate or modify the skin flora using live probiotics or maybe postbiotics, and there are some studies where people are talking about prebiotics as well. So the topical probiotics would actually, manage the stratobiome of the skin and produce a general overall skin health. There have been studies where people are talking that transient microbiome alteration could also have an effect. For example, for skin diseases, people often go and have thermal spas, and it is said that it is because of the Vitrucilla filiformis, which promotes the T regulatory cells and inhibits T cell proliferation and thus controls allergies. So this is also one area which is actually coming up in case of topical probiotics. We are yet to see therapeutic probiotics, but in cosmeceuticals, the companies are already claiming the use of probiotics, right from washes to soaps to gels to vaginal washes and things like that. But there are reports and there are several patents where the companies are claiming about skin rejuvenation, glowing skin, and so forth. So what are the actual challenges? What would be required of an ideal formulation for probiotics? One would be that the bacteria should be present in a sufficient number in the formulation, and they should be viable throughout the storage, throughout the shelf life of the product. then they should be able to withstand any adverse conditions until they establish themselves on the skin. Then for establishment, it is important that they are retained on the site of application for sufficient time till they establish, till they grow, till they regerminate and they adhere to the skin surface. And there should be a prevention from the washout. So again, so everything just siphons down to one thing, that they retain on the skin surface for a time where they establish themselves to actually modulate the skin microbiome. So these are some products which are in the market. Majorly they are postbiotics, majorly they are the probiotic metabolites, but some of them do claim to have live probiotics also. So the drawbacks of what is actually in the market, and so what I'm trying to do here is create a research gap. Where is an area, where is a scope where we as scientists can work? So there are very few products in the market which have wholesale probiotics. It is majorly the extracellular substances, bioactives, ferments, and so forth. So the ones which are containing wholesales, they are invariably powders, sprays, or they are oil-based and would not be suitable for oily skin types which suffer the most from the skin dysbiosis, like the acne prone skin. Then in addition to having probiotic, these products, they have a long list of ingredients, including some preservatives being added. And these preservatives would be a concern because they could, influence the viability of the probiotic present therein. The most commonly used species are Bifidobacterium and Lactobacillus, which are more suitable or more abundantly found in the gut than on the skin. And there are very few, as I said again, cosmetic applications are there, cosmetic claims are there, rather, I would say, but not the pharmaceutical applications, where I think there is a lot of scope for these topical probiotic formulations, including the control of acne, atopic dermatitis, wound healing, and so forth. So here is where innovation comes, and I talk of it as technovation, where you are trying to, create a technology or a process by which you would have an outcome which would have value for the people. And that is what we as academicians often, enter into, is entrepreneurship. And I have introduced recently a logo for my lab of innovation to reality. So these are a few endeavors we've been making over the last, I would say, 10 or 12 years, where we are trying to develop products which would have viable probiotics, which can be actually, transferred to the skin to manipulate the skin microbiome. So I would take of them one by one. This is the where we've prepared a gelatin-based emulgel. This was recently published, and as I already said, this is a work where Professor Parveen Rishi has been one of the collaborators. So what we did was we designed a formulation where we ensured that the probiotic would remain viable upon storage, but again, this point I think I missed out earlier, is that the probiotic has to remain viable, but at the same time, it should not start dividing, growing, germinating within the formulation. Then it would utilize the components of the formulation and it would foul the product. So you just want that the viability is preserved, but the growth is static. There is no, division of the probiotic. Then it should be easily applicable on the skin, and it should germinate there, and there should be a sufficient time for it to establish on the skin. So we also tried to include only cost-effective ingredients. As I said, one of the major ingredient was gelatin, which is not very costly. And then we also ensured that what we did here was we tried to control the water activity of the formulation, and that would manage two aspects. One, where I said I want my probiotic to remain in a dormant state, because the water activity is low, so it would not divide. And again, because the water activity is low, it assigns a self-preserving property to my formulation. Any other environmental contaminant would also not grow in my formulation. So we selected Bacillus coagulans here. The reason was that it is a spore and a facultative anaerobe, but it can grow and germinate under aerobic conditions, and the optimum temperature for growth is 30 to 55 degrees. So 55 degrees makes it capable of withstanding any production exposure of higher temperatures, and 30 degree because the skin surface is also 30 to 32 degrees. So this is the gel system which we developed. As I said, it was a novel system. We've already filed a patent application for this, and also we've transferred the technology to one biotechnology based industry. It is a polydispersed particulate system, which is different from normal gelatin systems, which are discs or films, and they use usually cross-linking agent. We did not use any cross-linking agent, which could be toxic to the skin or irritant to the skin. As I said, we maintained a low water activity of around 0.5 to sustain probiotic in dormant state, avoid germination, and assign self-preservation. Then we also added a humectant. So humectant is a agent which absorbs moisture. So now humectant was included in our formulation so that it can absorb moisture either from the environment if the skin is dry, and in case the environment is dry, then it can suck water from the lower layers of the skin, and that water would improve the water activity of the formulation and would help in the germination of the probiotic. And then we also added an oil and a surfactant. So oil was included to prepare an emulsion which would slowly release the probiotic on the skin surface so that it can adhere, germinate, and establish on the skin. And the oil also offered a protective covering to the probiotic. So these are a few pictures. This is the optical microscopy of probiotic loaded gel. This is the scanning electron microscope where we can see the probiotics within the structure. Then the cell viability was checked up to 3 months at 3 different storage temperatures. And since it was a spore, so we tried to confirm that the spores had not germinated. And as you can see that the cell counts in the formulations which were given heat shock to remove any vegetative cells versus no heat shock was same. And then we also confirmed the cytotoxicity of the formulation in lymphocytes. This is the skin toxicity in vivo in rats. And then we also did the translocation studies, and there was no translocation of the applied probiotic into the blood. And then we did the challenge test, which is a pharmacopoeial test to confirm the self-preservative nature of the formulation. We challenged the formulation with Staph aureus, Pseudomonas, E. coli, and a fungal strain Candida, and there was no growth. The challenged count was reduced within 7 to 14 days of being incorporated into the formulation. Then when we applied the formulation on the skin, within 24 hours, there was a significant germination of the probiotic from the spores to the vegetative cells. Then although we propound the formulation to have an anti-acne effect, but developing an acne model was not possible in the preclinical rat model was not possible because both rat and mice have a very high immune system. So it was not possible to induce acne into the animals. So we evaluated it for a wound healing model. And as you can see the probiotic gel, healed the wound within 7 days, as good as a marketed formulation, which was a betadine and a ceftriaxone formulation. Then this is a second study where we produced vaginal suppositories of the same organism, that is Bacillus coagulans, and we tested it for its weight uniformity, disintegration, total probiotic content, and hardness. Then the water activity was maintained low, release of the probiotic from the suppository matrix was monitored, and the melting at 37 degrees was monitored. swelling studies were done. And this is the retention. We stained the suppository with crystal violet or the starch iodine, and we could say that the suppository was retained within the vaginal tract up to several hours to release the probiotic. The histology as well as the pH of the suppository was within safe limits to avoid any irritation. There was no translocation, and it also showed good stability. The bacteria germinated within the vaginal epithelium. And this is the infected vaginal opening of the mice. And this is the treated animals. And again, you can see a very healthy, tract, vaginal tract versus highly inflamed tract in case of infected animals which were not treated. And again, we determined the candidiasis load in different groups. And again, we could show a significant effect. This is where we've combined a probiotic, Lactobacillus plantarum, with our with a patented technology of nanocurcumin, where we've encapsulated curcumin in solid lipid nanoparticles. And again, we have optimized a sponge dressing where we included various polymers. And again, a patent application is filed for the technology, and which ensured maintaining the moist environment, circulation of gases, protection against the bacterial load, biocompatibility, and in wound healing. What we tried to do here was, as I said, we've combined a probiotic with curcumin to have complementary effects. And the sponge was found to degrade within 24 hours when applied on the skin surface. These are the FESM images, and we can see the probiotics within the sponge dressing. And this was a very exciting, observation that this is a biofilm of Staph aureus, where we treated it with different concentrations of curcumin, and at a very high concentration of 2 mg per ml of curcumin loaded solid lipid nanoparticles, there was a significant disruption of the biofilm, especially the mature biofilm, which is being reported by our group for the first time. And similarly, when we exposed it to a probiotic and curcumin nanoparticles cocktail combination, again, the biofilm disruption can be seen. And towards the later stages, we saw a biofilm of the probiotic forming in the in vitro studies. This is the actual probiotic biofilm, and this is what happened when we treated the Staph biofilm with our combination of probiotic and curcumin. So this is, again, we did some wound healing studies, got very good results. So we could reduce the bioburden, we could downregulate inflammatory markers, matrix degradation and oxidative stress. We could upregulate growth factors and angiogenesis. There was an accelerated wound healing. There was germination of the probiotic, but no translocation. Recently, we have ventured into 2D electrospinning of the probiotic encapsulated nanofibers. And it is again proposed that this type of nanoencapsulation would protect against protect the probiotic against environmental factors, gut factors, and would achieve a targeted and a controlled delivery. This is what people are doing using different electrospinning methods. And this is what we have done in our lab. We have prepared the nanofibers which encapsulate the probiotic. And at the end, I wish to acknowledge a few of my students who've been working on various projects. Garima Sharma, Simarjot Kaur, she's already completed her PhD work. And Professor Parveen Rishi was one of the co-guides. And Mandeep is currently working on electrospun fibers, and Anchal and Manohar were 2 master students. And I end here where I say that everything about microscopic organisms is not upsetting. There are certain ups to it. Thank you.
Thank you so much, ma'am, for taking us to the world of probiotics, to the world of microorganisms. I completely forgot my chemistry here and was totally involved in your microbiology. And I'm sure people would be having some questions in their mind. And first of all, I must congratulate you for the marvelous work that you have done. In these few years, you have done so much of work, and especially in the field of patents. You are a big example for all of us. So for the question and answer session, I would like to invite Dr. Suman Singh, who is a senior scientist, principal scientist at CSIR CSIO. So Suman ma'am, please, if you could start the question and answer session. And if you, and amongst the panelists, if someone has a question.
Yeah, hello, good afternoon, everyone. And ma'am, it was a wonderful talk. And in fact, as Nishima said, that we were into the live demonstration of microorganisms, and we were just visualizing the things. And as said in the last, that they are not harmful always. So, this is a wonderful talk. Now, starting with the Q&A session, of course, if any panel member has any questions, they can post in the chat session. And in fact, very first question I would like to raise,
Sure.
you had been discussing about the probiotics for the topical uses, and it was an excellent work. My question is, you can say, being a mother also, like nowadays kids go generally ask for that Yakult.
Yeah.
And say that it's a full of
Probiotics. True.
So how this concept is true, whether there are really probiotics in it or it's just a media house?
No, I would say a combination of both. Yakult has significant probiotics, and there have been several study reports where Yakult is propounded to be a very good product, except for a few, downside news where there were certain reactions by some users. Now, the issue with Yakult is the cold chain, which has to be maintained. They have developed a multiple strain formulation, which is a very good formulation. But again, the compliance, the distribution is an issue. So there could be other alternatives. We've been working. I didn't show that data because I wanted to talk about skin and topical probiotics. So we have used some alginate beads, and we compare our product with versus Yakult, and we claim that this could also be an alternative where we maintain the viability. And because Yakult acha hai, it has a very good combination of organisms, but the adverse passage through the gut, every organism has to face if it is a free probiotic. तो उस वक्त क्या वो survive कर पाएगा, वो gut की acidic conditions, mechanical stress, because stomach में कितनी churning होनी है, and would it be able to deliver live probiotics up to the colon where they can establish, is a big question mark.
Yes, I think this is the biggest challenge also in.
But the thing is that, as I said, these postbiotics also work. These dead organisms also induce various immune reactions. So probably it is a combination of the live and the dead organisms which is acting. And if you can deliver more live organisms, that would be even better.
So I think especially in the Indian weather conditions, I think supply chain has a major role to play in determining the final efficiency of the probiotics when it is going to the human body. Thank you, ma'am, for this wonderful explanation. Now, one question is there from Ms. Neha. Can you please enlighten us about which type of polymer can be used in the preparation of the gel?
Okay, so there could be, I think we should prefer biocompatible polymers. I have been using alginates, gelatin, then pectin to an extent, but people have been using PVA, people have been using Zyme. So there are n number of options which are available in the literature, and it would depend upon the type of probiotic you are using, the type of technology you are going to use. So some polymer could be suitable for your technology and it may not be suitable for another technology, but there are several options available now, I would say.
Okay, and as you talked in the encapsulation in the polymeric matrix using electrospinning, so how it is ensured to have a continuous release also?
So because, these are nanofibers. So one is the surface area is enhanced, and the other is that the fiber, the polymer, it would have to be either water soluble or it has to be biodegradable, depending upon the route of application, I would say. Gut में कुछ और तरह का हो सकता है, आप बाहर polymer acid resistant लगा लो ताकि stomach में उसको save कर देगा, and then it can go and open in the colon because of the change in pH. It could be a pH soluble polymer, could be there. So it would depend upon the application, I would say.
Any other questions from the panels?
To allow, can I ask one question?
Yeah, Dr. Nishima, please.
Okay, ma'am, how do you actually electrospun those fibers? Do you use an spinning machine, or the same that is used for electrospinning polymers also?
2D printing के साथ ही, हाँ जी.
2D printing.
Because temperature नहीं increase होगा ना, invariably it is basically the charge की वजह से जो deposition होनी है. So, and we use a polymer solution, we incorporate the probiotic, like we've tried the both the coaxial spinning as well as the normal polymeric blends, and we were successful. We are yet to confirm the viability, but there are a few reports recently in the I would say that the concept is only 3 or 4 years old, but people have reported where they've shown good viability within the polymeric nanofibers.
And ma'am, another question in this line, sir. Can we use peptides to encapsulate these kind of materials?
I think we can give it a try, लेकिन peptide का अपना issue stability का या वो आ सकता है, so we'll have to see how to go about it, है ना?
Yeah, right. Okay.
अगर आपने oral use करना है तो फिर you will have to check. अगर कहीं और use करना चाहते हो, maybe like अभी I think periodontal application would be a very good application for these 2D films or scaffolds. And then on the wound, of course, we are developing it for wound or tissue regeneration. This is what we're trying to do.
I'll discuss it with you separately, ma'am.
Surely.
Surely.
My pleasure. If we can, मैं हमेशा कहती हूँ कि अब साइंस के barriers खत्म करने का time आ गया है.
Absolutely.
The chemist, the physicist, the biophysicist, all of them, the microbiologist, of course, all of us need to get together and do good
together. Yeah. Absolutely, ma'am. Thank you, ma'am.
Such events facilitate such type of networking.
Bilkul.
Yeah, that is why, just a minute, that is why I said that we have to come out of the silos and cross our boundaries and work together, whether you are a chemist or you are from the pharmacist background or microbiology. How Dr. Indupal has just given the best examples of her domain as well as the microbiology. So you see, Dr. Indu, excellently you have made the deliberations, and I would say you have made our day. You have made our day. Really.
Thank you so much.
I really don't have any words. Your deliberation was self-explanatory, and that fulfills the purpose why I wanted to bring you to this platform, because I wanted that other colleagues of ours should also hear your views. That was the only point, and that has been fulfilled. You have made our day.
It is an honor, in fact, to share the platform with my mentor, Professor Sophie, and you being there, and young people like Nishima being around. It has been an honor, of course.
And one thing more I would like to say, there are several kinds of collaborations, but in our case, this has emerged to be the best collaboration, the passionate collaboration, which I always enjoy.
Yes. True.
And we are really motivated when we meet, and we are in high spirits.
Sure. मैं हमेशा कहती हूँ, and this is a message to our young scientists who may be watching the YouTube live streaming. मेरा 99% सो नहीं होता जब तक वो 1% मुझे किसी अपने कोलैबोरेटर से नहीं मिलता. तो मैं चाहे 99 भी कर लूं, लेकिन वो 1% की कमी मेरे काम में रह जाएगी. And that is where collaborations need to come up. And I think कहीं पे हमारी Indian psyche में lack of trust है, lack of faith है, या I don't know, हम egoistic हैं. मैं अभी तक I have not been able to put my pulse on it, but I really feel कि बाहर की countries में, if you look at good publications, you would see 5, 10, 20 people coming together for a publication. We really need to do that. We really, and उसमें I think जो जैसे डॉक्टर परवीन ऋषि भी कह रहे हैं, उसमें सब लोग पैशनेट होने चाहिए साइंस के लिए. नहीं तो कई बार क्या होता है कि तुम डेड कोलैबोरेशंस बना लेते हो, वहां पे तुम कर रहे हो और दूसरा तुम्हारे उसमें काम में इंटरेस्ट ही नहीं लेता. सो वो कहीं ना कहीं साइंस के लिए फीलिंग, अगर पैशन आ जाएगा, तो आई थिंक वी कैन डू वेरी गुड साइंस.
Then adding to you that like Chandigarh is a place surrounded by so many institutes.
True.
It's a hub of institutes. So if this region only collaborate, then we can have very wonderful outcomes.
We have to come out of our, as Professor Praveen, silos, या हमारे जो कुएं के मेंढक है ना, हमें उसमें से बाहर आना पड़ेगा और ग्रो करना पड़ेगा.
Coming back to the next question, ma'am. What is the non-specific immune effect on the topical probiotics?
So non-specific immune effect में I would say जो आपके anti-inflammatory cytokines हैं, वहाँ से लेके type of skin barrier function establishment. I think Dr. Parveen Rishi may add a few more things to it.
नहीं वो होगा because non-specific में कितने non-specific, if we talk about the molecules, we talk about the complement system, we talk about the non-specific cells like neutrophils or macrophages. So that again, that is a combination of all factors.
I think
that is multifactorial.
Maybe there could be more studies, or if we look into the literature, maybe there are some studies, but I'm not actually sure about that.
Yeah, thank you. Next question is, how solid lipid nanoparticles release antibiotics to the skin?
So in this case, the study which I did was we prepared solid lipid nanoparticles of curcumin. So basically what solid lipid nanoparticles are, they are like a solid matrix. I would say, I don't know how many of you here know about emulsions. So basically an emulsion is an oil and water system. तो जब मैं oil globule उस oil को replace कर देती हूँ एक high melting point lipid के साथ, which is solid at room temperature. So basically, I would develop this system at high temperatures where the lipid is melted. I have an oil and lipid and water system. And as soon as I cool it, this lipid becomes solid matrix. And I have a drug or an antibiotic for that matter encapsulated within it. And since वो solid matrix है, तो erosion से, diffusion से, और different mechanisms से उसमें से active जो है वो release होगा. The studies I shared here were where I have encapsulated curcumin in it, which is a poorly soluble, poorly permeable molecule. So depending upon the antibiotic nature, you could have different types. And then depending upon the hydrophilicity and lipophilicity of the active could be present in the core of the, lipidic particles or in the shell. So, and accordingly, the release would be different.
Thank you, ma'am. Then the next question is, does the natural product-based materials show good results in the skin treatment?
Yes, definitely they do, but again the issue is कि जो market gimmick है, they just proclaim कि हमने ये डाल दिया और effect हो गया, और उसके साथ बहुत कुछ और डाला होता है, तो you cannot establish उस वजह से हुआ. And जितने भी natural molecules हैं, invariably they are unstable. Either they are unstable to pH or they could be unstable to the oxidation, because most of them are antioxidants and they oxidize very easily. Then they are insoluble. So unki skin permeability kitni hai, that needs to be established. And that is again an arena where the formulation scientist can step in.
Yeah, but nowadays every product, most of the products are coming with natural.
हाँ, मुझे ऐसे लगता है कि वो एक मिसनोमर क्लेम है, बिकॉज अल्टीमेटली उसमें सफेक्टेंट भी डाला उन्होंने, लिपिड भी डाला, तो वो सब तो सिंथेटिक ही है ना.
In fact, I had been discussing with some very renowned person who had been associated with such type of industry, and it was shared that yes, natural product is just 0.2%, 0.3%.
Yeah.
It is the how you publicize your product. Because ultimately for emulsions, you have to add other substituents of.
Yeah, now there is an onslaught of clean cosmetics के नाम से बहुत market जो है is being flooded. Sephora, US में बहुत सारे products आपको आ रहे हैं clean cosmetics करके. तो उसमें basically they are claiming कि hypoallergenic हैं या उसमें कोई भी ऐसा component नहीं हमने डाला जो कि irritations कर सकता है, types of things, you know.
Yeah, thank you. Could you please tell how nanoparticles can be used for probiotic formulations?
I'm not sure if nanoparticles can. I have not tried that. I have been thinking about it. But मुझे हमेशा लगा कि nanoparticles बनाने के लिए the conditions we are using could be adverse conditions, and probably we may not be able to incorporate probiotics into nanoparticles. We did, as I said, an emulgel we did prepare with gelatin, and we could get particles of around 800 to 900 nanometers, but they were again polydispersed. Some were small particles and some were bigger particles.
For probiotics, the term should be microencapsulation, not nanoencapsulation. What do you say?
Majorly microencapsulation, except for nanofibers में अब nanoencapsulation हो रही है.
You remember we made that microencapsulation double head probiotic flavors.
EGCG and उसके साथ भी फिर हमने किया था.
In chat session as of now we are done. There are no other questions. Any other discussion the platform would like to have? So please, sir, or anybody else?
So, Suman ma'am, are there no further questions on YouTube? So
yes, now we can go ahead. There are no further questions in live chat.
Okay. Thank you, ma'am. Thank you, Suman ma'am. So it was indeed a pleasure to listen to you, ma'am. And I would now like to propose a brief vote of thanks. I would really like to thank, first of all, our esteemed speaker who has joined us today, Professor Indupalkar ma'am, and taken us through this journey of probiotics, of nanobiotechnology, and of various other aspects of science, related aspects. I would like to express my deep sense of gratitude to Professor R.C. Sokti, who has taken out time from his really busy schedule, and he is not even in his own town, he is outside, and still he has joined here. Thank you so much, sir. We were really very encouraged by your words, and it is very nice to see you again here, though virtually, and we would like to meet you in person also next time in the offline lecture.
I would add, always energetic, always dynamic, and sir से जो vibrations आती हैं ना वो हमेशा motivate करती हैं आपको to do and to outperform yourself. Yes. Thank you so much, sir, for being here. It really means a lot.
आप लोग अच्छे ही इतने हो तो क्या करें?
नहीं sir.
आप लोग अच्छे इतने हो?
नहीं sir. But,
I'm also very thankful to Professor Praveen Rishi ma'am, and in fact it was her choice, it was her idea. She called me and said that I really want to have this webinar with Professor Indupalkar ma'am, and I immediately said yes. Everything will be done. You just set up a time with her and we will do everything to get her on board. And maybe next time, ma'am, we will plan to have some sort of a workshop or something on patenting.
Sure.
So
sure.
That will be great. That
yes,
will be...
yes.
Yes.
Yes, because I think it will be more useful to the research scholars.
That's what's needed now.
Yes,
that things are needed that बच्चों को grassroots चीजें नहीं पता है. बड़ी-बड़ी बातें करते हैं. We must take them to basics first, then they move further. Right. You have shown every wonderful thing, starting from skin structure to the microbiome and explaining all those things. And this was a wonderful thing. The evolution of your lecture was fantastic. So I must congratulate you, Dr.
Thank you so much,
for
sir.
this. And Parveenji for involving us to this program. And I really enjoyed
it's a pleasure, and your presence is a great motivation to sir. I wanted you to be here, and we really feel blessed.
That's okay. That's okay, Vita. Thank you. Thank you, Ilmar. Thank you, Nishma.
Yeah, just a minute, Dr.
My
Nishma.
thanks. Yes. Yes,
Dr.
ma'am. My
Nishma.
thanks are little left, so some of the people's names are left. So I would just quickly say, so I'm thankful to Professor Deepti Gupta, ma'am, because it was her idea, this WISE team. I'm really thankful to INYAS, the chair, Professor Rajendra Dhaka, for giving us the liberty to use this Zoom platform of INYAS, and the office staff also. I'm thankful to her, Ananya, and our WISE team. Dr. Suman is with us, and we have Professor Archana also, Professor Jagdeep, and all of us from the WISE team, and Dr. Pavitra as well. And also, I'd like to make a mention about the girls, the students who have designed the poster. Meghna and my PhD student Dipali. Meghna was already having her exams, still she managed to make the poster, and we made her do a lot of changes also. And my PhD student also helped her, so I'm really
Yes,
thankful.
I'm responsible for that.
No, no, sir. So I'm thankful to both of these girls. At night also, I kept on texting them, and she were doing. Both of them were really very helpful. So I'm thankful to all these people who were at the back working without any personal motive of theirs. So I'm really thankful to all of you. I'm thankful to the Vice Chancellor of Punjab University for allowing us to run this program over here, and thankful to all the faculty, scientists, research scholars, and to the YouTube viewers who were watching this program. Thank you so much. Thank you, ma'am. Thank you, sir.
Thank
I
you.
hope to see you next time offline.
Thank you. Madam. Thank you.
Thank you, everyone. Thank you.
A big thank to you, Dr. Nishma, for bringing us all together at this platform. Thank you so much.
True.
Bye.
Thank you.
Thanks are actually due to Nishima too.
And then we can go off air now.
Thank you, Ji.
Okay, Dr. Indu. See you.
Okay, Ji. Okay. Bye bye, everyone.
So, Ananya, we are off. Live streaming is off.
Yes, ma'am. I'll just switch it off. I'll end the meeting and it will end.
Yeah, I just want to talk to Praveen, ma'am, after the live streaming is off.
Okay, ma'am. I'll just do that.